It'll be about 1 minute here. If you look at your exam, you recall that we have several sections. The multiple choice questions were worth 3 points apiece. There were 22 questions altogether. Since there are 22 questions, you take 22 times 3, you wind up with 66 points. So you're going to see a score on the front page of your exam out of 66 points. That is the score that you got on the multiple choice portion. The second score out of 34 points is a score that you got on the handwritten portion. That score was determined by taking the number that's at the bottom right corner of the front page and subtracting that from 34. And that number on the bottom right corner, that is the total number wrong that you got on the handwritten portion of the exam. I then take the two scores, sum them together to get a score out of 100. I do this all in my head and I do it very fast. It is very possible that I'll make, it's not often, and don't tell anyone, it is possible that I sometimes make mistakes. And so if I did make a mistake on your scoring, please let me know. I do have, I did lie about what I'm going to write up there just a moment. I was going to say that I have the answer key out on the bulletin board. Forgot to put it out there. We're going to get a chance to do some problems here in a little bit. I'll run to my office and grab the answer key. I will tack it up on the bulletin board outside the hall here. I will leave it up until 9:30. It's up to you to check your answers. If you want to go through your exams with me, I'm more than happy to do so. Now that said, I'd like to introduce you to Jacob. I didn't even get your last name. He's from the Academic Support Center.
Hello. Yep, my name is Jacob. I'm from the Academic Support Center. I'm a tutor for chemistry and math and physics. But I'm here because I'd like to tell you about the ASC. We're open from Monday through Thursday, 8 to 7, and Fridays, 8 to 4. And the ASC is located right across from the bookstore downstairs. And you can just sit down with a peer tutor and ask them questions, or you can set up an appointment with our professional tutor, Ruth. She's also sometimes available for a sit down. You don't always have to set up an appointment with her. We also have these three-dimensional molecule kits, and we have computers down there, so you can be working on your mastery in chemistry and then just ask some questions to them.
And Jacob, how much does it cost?
It's free. So you can just walk in, sign in, and then sit down.
Now usually I do this, and Jacob had scheduled to do this before our first exam, but with whatever happened to the weather here, we missed class and everything. But I do expect to see Jacob and his friends down there in the Academic Support Center to be very busy now that you have your exam back with some tutoring services. And that shouldn't be when you go in. Afterwards, you should be going in when?
Before.
Right.
Exams.
Right. Because we want to do well on the exams, not do poorly and then find out what we did wrong. So, anything else you want to add?
No, unless you had some questions. Okay.
All right. Thanks, Jacob, for coming in. Statistics in the first exam, we had scores ranging all the way from 33 up to 100. Rare that I see this, but the ramp went upwards. That meant that we did well up here on this end, but also meant there's quite a few of us down here on this other end that you probably don't want to be on. What I will tell you is that as far as exam difficulty goes, exam 1 is usually one of the top 2 scores of the semester. So that is on the average. That doesn't mean that's the case for every person, but if you're looking at and you're sitting there with a score right now of about a 50 or 60, 70 or whatever, and you're not happy with that, I can 100% guarantee you that the material in here is not going to be getting any easier. Now, actually, it doesn't get any more difficult. It's just that it's cumulative. If you haven't gotten this stuff at the beginning, chemistry is a subject that builds on what we previously learned. If you have a crummy foundation, you can't build on a crummy foundation. You need to get those skills up there. And one of the things that I often say is if you want to get good at something, what do? Practice, right. And you know, people come to me and want to know, how should I study? What's the magic solution? I can maybe give you some tips on how to study or ask you what you've been doing. But really, if I want to shoot baskets better, what am I going to do? Shoot more baskets. Got to practice. If I want to play my ukulele, which I'm starting to learn, if I want to play that better, what am I going to do? Practice, exactly. And if you want to get better at chemistry, what are you going to do? Practice. All right? But that's kind of where we're at with everything. The Academic Support Center, again, provides their services for free. If you want to talk to me about your exam, I am also more than happy to talk to you about your exam anytime during office hours. Your grades to date have been posted because there was a delay in, I believe it was lab number 2 for some of us. That is not posted a lecture grade, or lecture D2L, but you should still be able to see your scores there on the lab side. You should keep working on mastering chemistry, and then of course remember to prepare for and attend lab. Any questions? Any questions? Okay, if you came in late, there are a couple handouts here. Why don't you come up and grab one of each, please? And let's talk about your expectations here with each of these sheets. The handouts are right there.
Sorry about
Okay, now, if we look at the one handout here, this is a list of ions that you will need to memorize. Now, this is not all that we're going to be learning in here. You are going to be responsible for knowing more ions than this, but there's going to be a system for learning some of the names and formulas for these ions. But at a very minimum, there's no real system to learning these. When you look at these, one of the things that we should pay attention to, first of all, this here is talking about polyatomic ions. So if we look at what the prefix poly means, the prefix poly means what? It means multiple or many. So these are going to be many atomed ions, and these are some common ones. Now if you look at the ones that you're memorizing, what do most of these have in common with each other?
8.
Most of them end with 8 at the end, exactly. So if you look at these, most of them that you're memorizing have a suffix that ends with ATE. And if you look at the ones that have a suffix of ATE, what do most of these have in common that have this suffix? They have a negative charge, exactly. So again, as you look at them, they'll have a negative charge. What else do they have in common?
Have a carbon?
Most of them do not have a carbon.
Oxygen.
They have oxygen. Most of them contain the element oxygen. So again, as you look at this, most of these here will contain the element oxygen. Now, unfortunately, what would be great is that all of them that ended with ATE, if they would all have 3 oxygens, and they don't. But what I will tell you is if you see a suffix of ATE, all the time it will have some oxygen in there. So as a rule, if the name ends with ATE, it's always going to have some oxygen in there. Unfortunately, again, the number of oxygens is going to vary, and that's why we need to memorize. Also, if it ends with ATE, you'll always see that it has a negative charge, but the amount of negative will always vary, unfortunately. And again, that's part of the reason why we need to memorize. And you might say, well, why don't we come up with some rule where everything that has 3 oxygens ends with 8? Well, the reason for that is it turns out that there's some history associated with this. And the history is this, is if we went out into nature and found something that contains phosphorus, it turns out they were first named before we knew how much oxygen was in them. So we called them phosphates, phosphate rocks. And if we found something out in nature that had sulfur in them, turns out that we called them sulfates. And later on we found out that they had 4 oxygens in there. So again, we discovered these things and named them before we actually knew what the amount of charge was and how many oxygens they had. And so those names stuck, and we built our naming rules around what we first learned historically. Now, from that, you'll see that the only positively charged polyatomic ion you're responsible for here is the ammonium ion. We'll find out in our naming rules that many of those that have, many things that have the ammonium ion have some exceptions to the rules. And we'll talk about those in a bit. Over here, there are some positively charged ions that you are supposed to memorize. These are common metal ions. this is not at all a complete list. In fact, you need to know many, many, many more than what's shown here. However, we're going to have a system for learning some of the other charges that are on the polyatomic ions. As far as the area of study that we're looking at this portion of chemistry that's called chemical nomenclature. And we use the word nomenclature. The word nomenclature stands for a systematic method of naming. Nomenclature stands for a systematic method of naming. And each discipline has its own set of nomenclature. For example, you don't run around talking much about subject and predicates here in chemistry, but if you were in English, subject and predicate is going to mean something, and that's the type of nomenclature that's used in English. Or if you're in the medical field or biology, you might talk about anterior and posterior. Usually we don't talk much about anterior and posterior or dorsal and ventral, but if you're in the medical world or in biology, those terms become very important. So same in chemistry, some of the stuff we won't use beyond here. You'll hear about them, but you probably won't use them much. But there is a systematic method of naming. Spelling is going to be important. I believe, like we talked about in day one, if we look at something like Cl, you already know this one. Cl stands for chlorine. But when we talk about Cl with a negative charge, this is going to be chloride. This would be chloride. And if we look at ClO2 with a negative charge, this is going to be chlorite. And if we look at ClO3, sorry, see if I can get this thing to work here. Not working. ClO3 with a negative charge. This here is going to be the chlorate ion. And so you can see that these differ from each other by one letter, and they will vary in their suffixes. The first portion of the name is what we call the root name. The root name. And the root name is the first one or two syllables of the element's name itself. So in the case of chlorine, we'd say that the root name of chlorine is chlor. Or for oxygen, the root name of oxygen is ox. And then we find out we'll be adding some different suffixes onto those. Now, once again, you are going to be expected to know some other ions besides the ones that are listed here. To get an idea what some of those are, if you have your text, you look on page 143, and we'll talk about this more at the end of the hour today or at the beginning of the hour tomorrow. But, for example, I've underlined here, you are going to be learning the nitrate ion. That's the one you're going to memorize. You're going to memorize nitrate, but you'll be expected to know the formula for the nitrite ion. If we come back here to, let's see, sulfate. Sulfate is the one that you'll be memorizing, but you'll also be expected to know the formula for the sulfite ion. And if we come back here to chlorate, chlorate is the one that you'll be memorizing, but you'll also be expected to know the formula for the chlorite ion. And if you look closely at these, again, this is kind of where the rules begin. Notice what is the difference between those that end with an ATE suffix and those that end with an ITE suffix?
The 2 and 3, the subscript.
The subscript varies. In fact, they vary in a very expected manner. If you look at nitrite and nitrate, the nitrite has how many oxygens compared to the 8?
2.
Well, it has 2, but comparatively speaking, 1 less. If you look at sulfate and sulfite, the one with the ITE suffix has 1 less. If you look at the ATE and ITE for chlorate and chlorite, the one with the ITE suffix has 1 less. So if you memorize the one that has the ATE suffix, which is the one that is on your list to memorize, then you should be able to get the formulas for those that have an ITE suffix because the formula for the ones that has an ITE suffix will always have one less oxygen than the one that has the ATE suffix. So again, you are memorizing the ones, however, that have the ATE suffix, but you will be expected to know the ones that have the ITE suffix as well. And that's a just for example. Okay, any questions? Okay, next up. Let's look real quick here at the questions you had coming in. These were your Socrative app questions. When we get into some of our nomenclature, our ability to count atoms is going to become very important. So your first question on this one was how many calcium ions are represented. Let's see if I can zoom in on this bit. How many calcium ions are represented in the formula of Ca3, parentheses, PO4, parentheses 2, which by the way is calcium phosphate? Correct answer here is 3. It is 3. And to get that number, all we need to do is to look at the subscript right here. So subscript on calcium is a 3, and that is a count, and that's why we have 3 calcium atoms. If we want to look at the number of phosphorus atoms in here, the correct answer on this one is 2. A few more people got this one wrong, but if you look at this, what is the subscript on the P?
Nothing. But
There's nothing. If there's none there, the number that's implied is the number 1. So if there's a 1 implied, but we have it in parentheses, this 2 means that we're going to take that number and multiply it by 2. So 2 times 1 is going to give us 2 altogether. And then if we look at the last one, how many oxygen atoms are represented in the formula for calcium phosphate? Correct answer on this one is 8. And again, we get that number by taking 2 times 4, giving us a total of 8. Any questions on this one? Okay, then let's look at types of compounds. Types of compounds that we're going to distinguish between are going to be ionic compounds, and I don't like this. I'm using my small stylus, which I am not very good at using. There we go. Ionic compounds and molecular. And we're going to make a table to make that distinction between them. First thing we're going to say is that if it's an ionic compound, we are going to have metals bonded to nonmetals. Metals bonded to nonmetals, and that is going to be with one class of exceptions. And that class of exceptions includes ammonium compounds. Includes ammonium compounds. And so if we come back and look at our table of ions that we were to have memorized, in our table of ions to memorize, what was different about the ammonium ion in this list? It has the only one there that you are to memorize that has a positive charge on it, exactly. All the rest of the polyatomic ions you're memorizing have negative charges, but the ammonium ion is the only positively charged ion you are memorizing. Okay, on the molecular side, these here are ones that involve nonmetals and or metalloids bonded to other nonmetals or metalloids. So it could be a nonmetal to a nonmetal, nonmetal to metalloid, or metalloid to metalloid, and those types of elements are molecular. Those types of compounds, sorry. And if we look at the periodic table, where do we have that division between the metals and nonmetals? How do we find that separation?
Oh, aren't they dark? They're shaded.
They're not shaded, no. Staircase, exactly. So if we look at this staircase right here, this staircase separates the metals from the nonmetals. On this side over here we find metals. Over here we find nonmetals. So where do we find the metalloids?
On the side, left, right of the staircase.
Right along the staircase. All of the elements right along the staircase except for the element aluminum, which is a metal. And the only nonmetal that appears on the left-hand side is hydrogen. Hydrogen is the only nonmetal that appears over on the side of the periodic table. Okay, next up here. Another thing that will distinguish between these is we say that in an ionic compound, the atoms are joined by ionic bonds. And when they are joined by ionic bonds, we say that electrons are transferred. Now, we don't talk much about bonding at all in this particular chapter. We do discuss bonding later on in this course. Right now, we are laying a little bit of a foundation. On the molecular side, we say that the atoms are joined by covalent bonds. And in this case, we say that electrons are shared. And so this is the main distinguishing feature between them. Now, in order to succeed at nomenclature, we have to classify compounds. And so we're going to look at classes of compounds. And we look at the classes of compounds because each one of these classes, there's 5 different ones, each class has its own set of rules that's different from the others. So the first one is what we call binary ionic compounds. The second one is what we say are ionic compounds with polyatomic ions. Third category is binary molecular compounds. Fourth category is binary acids. And the fifth category is oxyacids. So I'll read them again. First is binary ionic compounds. Second is ionic compounds with polyatomic ions. Third is binary molecular compounds. Fourth is binary acids. And then the fifth is oxyacids. And once again, in order to have success with nomenclature, you have to be able to correctly classify them according to these terms. So let's look at things that we've already defined in here. Which terms have we already defined in this list? Ionic, we've defined. So we've already defined what ionic are. If they are ionic, we would expect to find metals bonded with nonmetals. Okay. The other thing we've defined is molecular. In molecular, we expect to find nonmetals to nonmetals, or metalloids. Chemically speaking, the metalloids behave a whole lot like the nonmetals. So sometimes I won't talk about the metalloids, but chemically speaking, they often behave like nonmetals. Now, then the word that we see a whole lot in here is the word binary. The word binary means 2. So if it's binary, that means it's going to contain 2 elements. So a binary ionic compound, we would look at what that would mean. A binary ionic compound would be a compound that contains how many elements? 2. One of which must be a metal, the other of which must be a nonmetal. If it's a binary molecular compound, how many elements will it contain?
2.
2, and both of them will be nonmetals. So again, that's kind of how you analyze them once we begin. Now if we look at number 2, this is an ionic compound with polyatomic ions. Remember, poly means
Multiple.
many or multiple. So these are multiple atomed ions. And where do we find those multiple atomed ions? Ooh, that's on our list to memorize, all right? So these are going to be ionic compounds that contain these multiple atomed ions. In other words, it's going to be more than binary. Binary will just contain 2 elements. These here will probably contain 3 or more because they'll contain a metal combined with one of those many atomed ions. Okay, then a word we haven't defined in here yet is acid. So let's define what an acid is right now. Acids. We'll put it right here. Acids. These contain the element hydrogen. And that hydrogen is written at the front of the formula. And so if it's a binary acid is going to contain how many elements? 2, one of which is going to be hydrogen, and the hydrogen will be written where? In the front. So then if it's an oxyacid, that must mean it also includes the element oxygen. And the other element that must be in there is hydrogen. But it's not in binary acids. That must mean it will contain more than 2 elements. Because if it contained only 2 elements, it would be a binary acid. So with this in mind, let's practice these 6. Identify them by category. We have H3PO4, HI, Na2SO4, Ag2S, SF6, and Ti, and then in parentheses, C2H3O2, parentheses 4. So tell whether each of these belongs to which category. Is it a binary acid? Is it a binary molecular compound? Etc. And I am going to put these all up on the Socrative app. And I'll put them in open navigation. All right. So go ahead and work on these, and I'm going to go and grab the exam and I'll post it up. 4, 3, 2, 1. First one, H3PO4. This one here would be an oxyacid. It's an oxyacid because, first of all, acid because it contains the element hydrogen, also contains the element oxygen. Where's the hydrogen written? At the front. If it's the front, that makes it an acid. So only D and E are possible. It's not binary, and it does contain oxygen. That makes it an oxyacid. Any questions? Next up, HI. This one here is a binary acid. It's a binary acid because it contains the element hydrogen written where? At the front. And how many elements are there? Just 2. That makes it a binary acid. Any questions on that one? Okay, next up, sodium sulfate. This one here is an ionic compound with a polyatomic ion. Why can't it be binary?
Because there's not 2 elements. It's
More than 2 elements, exactly. And why can't it be molecular?
because it's not.
We have metals and nonmetals. If it's metals and nonmetals, it has to be ionic. Okay, next up, Ag2S. This one here is a binary ionic compound. Why is it binary?
Because there's 2 elements.
two elements, and it's ionic because metal with a non-metal. Okay, next up, SF6. This one here is a binary molecular compound. Binary because it contains two elements. It's molecular because
It's non-metal, so metal.
non-metal to non-metal. Non-metal to non-metal, that makes it molecular. And then the last one here, titanium acetate. This one here is choice B. This is an ionic compound of the polyatomic ion. Can't be an oxyacid. Why not an oxyacid? No hydrogen out here at the front of the formula. Any questions on these? Okay, now all we've done thus far is talk about classifying them. We haven't talked about naming them. You can't name unless you can classify. If you can't classify, again, you can't name. So the two accompany each other, and that's because each of these classes has its own set of rules. And so we're going to go in order, and we're going to start by looking at the binary ionic compounds. Binary ionic compounds. And we're going to start with one that most of you already know. Here it is. This one. First of all, how about the formula for this one? NaCl. How about the name for this one? Sodium chloride. Exactly. Now, here's how the rules go. First of all, it's a binary ionic compound because how many elements are there?
Two.
There's two. And those two elements, we have a metal and a non-metal. So the rules work like this. We say that the metal retains its name, and the non-metal that's present, we say that this retains its root name. Again, we talked about the root name, that's the first one and two syllables of the element's name, onto which we add a suffix of IDE. So the root name of chlorine is chlor. Then we add on a suffix of IDE, that makes it chloride. That means that if we want to write a name for something like this, Al2S3, this would be called aluminum sulfide. Aluminum. Spell it right, first of all. Aluminum sulfide. Again with the IDE suffix. Next one, Ba, Br2.
Barium bromide.
And barium, what would be next?
Bromide.
Bromide. Barium bromide, again with the IDE suffix. Na3N, this would be?
Sodium nitrite.
Be careful on the sodium
Nitrite.
nitride, sodium nitride. Again, these all end with the IDE suffix. Now going in reverse, gets to be a little more complicated. And for this one, we probably need our periodic tables out. So let's get them out. And we're going to be writing some more on these. How much writing do we have? Let's go ahead and pass one out to everyone here, because I see a bunch of writing already. So I've said before, you can never have too many. Too many, wallpaper your room, study, stick them to the ceiling, stick them to the walls. in the back. Thank you. All right. Now, let's say that we'd like to name something like lithium fluoride. Lithium fluoride. And by the way, spelling is important, so we'd spell fluoride as F-L-U-O-R-I-D-E. Lithium fluoride. Now, to do this one, we need to know charges based on their position in the periodic table. So, starting with group 1A over here, in ionic compounds, these here would always have a charge of 1 plus. Remember when we show charge, the sign always comes after the number, so it's 1 plus. Everything in group 2A would have a charge of 2 plus. Skipping over to group 3A, way over here, everything in group 3A, these would have a charge of 3 plus. Then going in reverse, starting from group 7A. Everything in group 7A would have a charge of 1 minus. Everything in group 2A would have a charge of 2 minus. And the nonmetals of group 5A would have a charge of 3 minus. And again, that's only to the nonmetals. It would only apply to these two right here. In fact, metals always have positive charges. Nonmetals always have negative charges. So again, metals have positive charges. Nonmetals have negative charges. For the rest of them, we're going to talk about those as time comes. We're going to find out that they have multiple charges. These here in group 4A, these, at least the nonmetals, like these right here, aren't very common in ionic compounds. And we will be talking and using these here a bit later. We'll talk about how we would write formulas for those. So for right now, if we want to write a formula for lithium fluoride, we'd find lithium in the periodic table. We'd find fluorine. We see that lithium is in group 1A, so its charge is 1 plus. Fluoride is 1 minus. And our objective here is to balance charges. So to write out the formula of Li positive and F negative, the total of the positives must balance the total of the negatives. Well, that's already the case. So to write a formula for lithium fluoride, we'd simply write it as LiF. Let's do it next for sodium oxide. Sodium oxide. Now to do it for this one, let's look up sodium on the periodic table. Sodium would be Na with a charge of 1 plus. Oxide is O with a charge of 2 minus. So again, Na with a charge of 1 plus, O with a charge of 2 minus. Now we're deficient in which charge in this one? In other words, which one do we need more of? More sodium. How many more? One more. One more will balance the charge. So now we have 2 positives balancing 2 negatives. Then when we write the formula, the final formula is always written without indication of charge. Subscripts are a count of the number of atoms, just like we started with here today. So the formula would be written as Na2O. Na2O. Now, if you had a high school teacher that allowed you to keep charges in here, your high school teacher taught you wrong. Okay? We don't talk about Na positive Cl net. You didn't come in here talking about that as a formula. You said that the formula of sodium chloride is NaCl. So when you write the final chemical formulas out, final chemical formulas never show the charges on the ions that make up that compound. Let's do another one. Let's look at strontium iodide. Strontium iodide. Going back to the periodic table. Strontium, 2 plus. Iodide is, over here, 1 minus. So we have strontium. with a 2 plus charge, iodide with a single negative charge. To write the final chemical formula,
Only one more.
we need more of which one? Iodine. How many more? One more. So now the charges are balanced. We have 2 positives balancing 2 negatives. Final chemical formula would be SR I2. Let's do this one. 2 more. Magnesium iodide. Magnesium iodide. Going back to the periodic table. Whoops, not magnesium iodide, I'm sorry.
Manganese.
I wanted magnesium sulfide. Sorry, magnesium sulfide. So the magnesium iodide would be just the same like as strontium iodide. Let's do magnesium sulfide. So we come back. Magnesium is Mg with a charge of 2 plus. Sulfide would be S with a charge of
2 minus.
2 minus.
We don't need
So now if we have Mg with a 2 plus, sulfide is S with a 2 minus.
MGS.
Final chemical formula would be
MGS.
MgS. Charges are already balanced where the sum of the positives equals the sum of the negatives. And then if we add something like this one here, let's look at aluminum. Aluminum oxide. Aluminum oxide. So we go to the periodic table. We find aluminum. Aluminum would have a charge of 3 plus. Oxide is O with a charge of 2 minus. So we come back here. Al with a 3 plus. O with a charge of 2 minus. Okay, now in this case it's not clear. If we add another aluminum, that doesn't balance it, but if we add another oxygen, it doesn't balance. Charges can't change. So what we do now is we find the least common multiple between the absolute value of these integer values. Or in other words, we look at the 3 and the 2. The least common multiple between 3 and 2 is 6. So how do we get 6 positive charges?
We need to add 2 more oxygen and 1 more aluminum.
All right, 2 more oxygens and how many more aluminum?
1 more.
1 more. So now we have 6 positives balancing 6 negatives. Your final chemical formula in this case is going to be Al2O3. Al2O3. Any questions with these here? Okay, let's try these for practice. We'll put down number 1, Li2S. Number 2, Ca3N2. Number 3, potassium phosphide. And number 4, barium oxide. If the formula is written, give its name. If the name is written, give its formula. And then if you think you're really smart, then do these 2. And I believe I have these on your Socrative app, or I will. That's a 9, yep. Oh, I don't think I meant to do all those. Just do the first 4. Don't do all 6 of them. Think just the first 4. Just the first 4. You will not get 5 and 6 right based on what we know thus far. So just the first 4. We've not covered 5 and 6 yet. So again, just the first 4. Again, just the first 4. End with barium oxide. And then if you get those, you can try your bonus questions. Give me about 30 more seconds. Okay, get your answers locked in, please. Count down. 5, 4, 3, 2, 1. Correct answer on Li2S is lithium sulfide. Very good. Next up, name of the compound that has a formula of Ca3N2. This one here is calcium nitride. Remember, if it has an ATE suffix, which element must be present? Oxygen. Exactly. We haven't talked about those that end with ATE yet, so B should be an impossible choice. Number 3, formula for potassium phosphide. This one here is K3P. Very good. K3P. And then formula for barium oxide. It's not BO, it's, yeah, some of you might have BO, but it's BAO. BAO is the correct formula. So any questions? Any questions on these? Last call. Let's look at the bonus question. Anybody get BaNA2? Well, there's something wrong with this formula, actually. What's wrong with it? Well, not only is it not balanced, it could never be balanced. Why could it never be balanced? They're both positives, exactly. We can't combine a positive with a positive. But if you want to be a comedian this early in the morning, you could always have a banana. And if you look at the next one, any idea what this one is? Now this one you just need to read the name of the formula. And maybe you got it already. Yeah, she's got it already, right? What is it? K9P, exactly. K9P. Hey, how about that? You guys just need a little wake-up call here this morning. All right, let's go on from here. Now, we left off some elements here in the middle portion of the periodic table. And the reason why we left some of these off is because these here have variable charges. Okay, some of these here have variable charges. In fact, most of them here have variable charges. And I'm going to mark these in blue. These here have variable charges. And by that, what we mean is that in some compounds they have one type of charge, in other types of compounds they have a different type of charge. Now it turns out that there's 3 exceptions in here. And those 3 exceptions are ones that you were to have memorized. In fact, right here, these are 3 exceptions, and those are ones that you were to have memorized. And you're going to find those on your list right back here of the common metal ions where you need to memorize charges. These here have fixed charges. These 3, the cadmium, silver, and zinc, they have fixed charges. So if we come back here, silver has a charge of 1 plus. Zinc has a charge of 2 plus, and cadmium has a charge of 2 plus. Okay, so all the rest of them, though, in the transition elements have variable charges. Now, in addition, these that sit over here have variable charges as well. So I'm color coding these. This blue box right here, these also have variable charges. So those 6 elements in there, they also have variable charges. So now, how do we distinguish and use these? Well, here's how we go about doing it. Let's stick another one in here. If we want to look at iron, iron happens to be one of the transition elements located right here. The 2 different types of charges for iron, or the 2 different types, are this type, iron 2 and iron 3. Iron 2 and iron 3. Iron 2 is Fe with a 2 plus charge. Iron 3 is Fe with a 3 plus charge. Now let's see if you can make the connection, except going in the other direction. Let's say that I tell you that these are the 2 different types of copper. Cu with a positive charge and Cu with a 2 positive charge. What do you suppose the names are for these 2 ions? So write down the names. Write down what you think to be the names. Compare with the neighbor. Looking at what you see here to the left, and how I arrived at these names and these formulas, we see these formulas. What do you think their names would be? First one is going to be copper 1. And where does that Roman numeral come from? From the charge. It's that simple. So the next one must be copper 2. It is that simple. Copper 1 and copper 2. The Roman numerals are equal to the charge. And that's why there's no need to memorize what these charges are. We simply say that they're variable, and their charges are going to be identified based on Roman numerals. So if I went to nickel, there's nickel 2 and nickel 3. So nickel 2 is going to have a charge of 2 plus. Nickel 3 will have a charge of 3 plus. Now, back in my day, we had a different way where we had to memorize them. We instead of using these names, we used the names ferrous. This first one was the ferrous ion, and this bottom one was the ferric ion. In the case of copper, this one was the cuprous ion, and this one here was the cupric ion. And we've replaced these now using these Roman numerals, so we don't have to learn these Latin names. Because part of the confusion is that the ferric had a 3 plus charge, but in this case the cupric had a 2 plus charge. So the IC suffix did not designate charge. And it's the same problem we have when we talk about nitrate, sulfate, phosphate, and everything. The number of oxygens differ. Used to be by using these Latin names that the number of charges differed. We've standardized that, at least for the positively charged ions, and simply refer to them with their name followed by a Roman numeral. So then when it comes to writing formulas, if we had to write a formula for iron 2 oxide or iron 3 oxide, it'd be quite simple. Iron 2 oxide would simply be Fe with a charge of 2 plus. Oxide is O with a charge of 2 minus. So then O had a charge of 2 minus. So now to balance charges, our formula would simply be Fe O, because the 2 positive balances the 2 negative. If we want to do iron 3 oxide, a Roman numeral of 3 would indicate that the charge on the iron is 3 plus. But oxygen is always going to maintain a charge of 2 minus. Well, now we need to balance charges. So to balance charges, we use the least common multiple. Least common multiple between 3 and 2 is 6. How do we get 6 positive charges?
Adding 3 to the O and 1 more to the
How many irons do we need altogether? How many oxides do we need altogether? 3, exactly. So then to write this formula, the final formula is going to be Fe2O3. So then if we saw something like this one here, let's say that we had titanium 4 sulfide. Titanium 4 sulfide. That Roman numeral 4 is not very good. Try it again. There we go. So now that must mean that titanium has a charge of 4 plus. Sulfide 2 minus. Sulfide right there. So charge is 2 minus. Now to balance charges, which one do we need more of? How many more? 1 more. So the final chemical formula is going to be TiS2. Now the point I want to make here in doing this is remember that this Roman numeral does not refer to any numbers of atoms that's down here. That it doesn't. The Roman numeral 4 corresponds to the charge right here. See, and the Roman numeral always refers to the charge. It does not refer to the number of atoms that we see in the formula out here at the end. So then if you had to work backwards, let's say that you had to work backwards on these. Let's try this one. Let's have CuO and Cu2O. Let's write the names for each one of these. Let's write the names. CuO and Cu2O. Now whenever we have multiple charges or variable charges, we must show the Roman numeral in the name. Not in the formula, but the Roman numeral must always be shown in the name. We can't write simply copper oxide. Let's try these out. The Roman numeral on the first one is going to be copper 2. The Roman numeral on the second one is going to be copper 1. Now, where do these come from? Remember that the charge on oxygen is always 2 minus. So if this formula shows one of each atom, the charge on the copper must be how much? 2 plus, exactly. 2 plus, and that means we're going to get one of each in that formula. Whereas if we go to the second one, again the charge on oxygen is always 2 minus. But how many coppers are shown in this formula? 2. So if there's 2 shown, what must the charge on each one of these coppers be? Must be 1. Exactly. So you kind of need to work backwards to figure out what those charges are, and then from there, that determines that Roman numeral. So now that should take you. You should be able to answer question number 5 on here. The proper chemical name of Cr Br3. CrBr3. I'll give you about 30 seconds to lock in an answer here. And maybe some of you got kicked out.
Well, where do I click submit? Because you asked us to answer the first 4 and then.
Yeah. All right, so we'll count down on this one. 5, 4, 3, 2, 1. Correct choice is D, chromium 3 bromide. Chromium 3 bromide. Now, we have to put the Roman numeral for chromium 3 in there, because where is chromium located? In the variable charges. And so if you look up the bromine has a charge of 1 minus. If you know that the charge on the bromine is 1 minus, and in the formula we had a total of the 3 bromides, so that must mean it's balanced on the chromium with a charge of 3 plus. And so that's going to make it chromium 3 bromide. And here's where we're going to end for today. So when you came in today, I said that there's going to be more ions that you were to need to know. Not to memorize. The ones you need to memorize are the ones that are on this list right here. These are your to memorize ones. But not only do you need to know those that end with an ATE suffix, but you also need to know those that end with an ITE suffix. So if we look at these again very carefully, you're memorizing the ones that end with ATE, but you will also need to know those that end with an ITE suffix. And as we looked at them, how does the one with the ITE suffix compare to the ones with the ATE suffix? Always has 1 less oxygen. Notice what happens to the charge if we compare sulfate to sulfite. The charge stays the same. Go to chlorate to chlorite. The charge stays the same. Nitrate to nitrate, what happens to the charge? Stays the same. So now, with this in mind, let's say that we have the phosphite ion. And we wanted to know what is the formula for the phosphite ion. Now, if you look on this list here on yours, you're not going to be able to find it. You'll be able to find phosphate. Phosphate is shown right here. It's on your list. But what is the formula for the phosphite ion? And that is on your app, on the Socrative app. What is the formula for the phosphite ion? And again, maybe some of you got locked out earlier. So we'll answer your questions. We'll count down. 5, 4, 3, 2, 1. Correct choice is A, It's going to be PO3 with a 3 negative charge. And the reason why it's PO3 with a 3 negative charge is because what is the formula for the phosphate ion? Right, it's always one less. So if you've learned and memorized that the phosphate is PO4 with a 3 negative charge, that must mean that the phosphite ion is PO3, the 3 negative charge. Now for, what is today? Tuesday. So for Thursday, here's your expectation for Thursday. You need to have memorized this list of polyatomic ions. If you do not have this list of polyatomic ions memorized by Thursday, you are going to find yourself behind, as well as these common metal ions. You need to have those memorized by Thursday. In addition, you should have these prefixes memorized by Thursday. These are Greek prefixes that stand for a given number of atoms. Now most of these you already know. These are on page 149 in your text, but they're the prefixes mono, di, tri. Tetra may be new to some of you. Penta, hexa, hepta, octa, nona, and deca. And then we're going to knock off the other, whatever it is, 4 classes of compounds on Thursday. Any questions? Okay, be safe on the roads out there today, please. That's it.